Okay, good evening, everyone.
Good
So you
evening,
are
sir.
welcome to
Good
tonight's
evening, sir.
class. You are welcome to tonight's class. So today
Good
we are
evening,
going to.
sir.
Good evening, ma. Good evening, sir. So today we are going to be looking at the probability and probability distribution function. Probability and probability distribution function. So I will I will start now. Then I will by one after 1 hour, I'm going to give room for 2, 3 questions after 1 hour. So if you have any question before that time, you can just keep it till about 1 hour. So I'm going to give room for question. So let's start. Can you all see my screen?
Yes,
Yes,
sir.
sir.
Yes, sir. We can see it.
Okay, sir. Okay, ma. So we are starting with the probability and then we move to probability distribution function. So let me start. Then before I start, what is probability important? And then we make use of probability in our day-to-day activities. We make use of probability in our day-to-day activity. We may not know that we are using probability, but in actual sense, we are using probability. If I ask us now that, can we mute our mic, please? So if I ask us now that, okay, what is the probability that tomorrow is going to be Saturday or tomorrow is going to be Monday? So you are going to tell me, okay, if I ask that, what is the probability that in this particular course that you are preparing for, you are going to have an A? What is the probability that I'm going to get to school tomorrow by 8 p.m.? What is the probability that when I get home, I'm going to meet light? What is the probability that, okay, the lecturer that is taking on is going to come to class tomorrow? So in every day-to-day activities, we make use of probability. And I want us to understand something, that anytime we are using probability measure what we call uncertainty, something that is we are not sure that is going to happen, but we know that there is likelihood that is going to happen. We may not be sure, but we know that there is likelihood that is going to happen. So anytime you are basing your assumption on uncertainty, something that is not really certain, then we make use of what? We make use of probability. Let's say, for instance, now, if I ask now, okay, in the class of 20, that I have what? That I have 5 female and 15 male. Okay, what is the probability that if I pick anybody is going to be female? What is the probability that if I pick anybody is going to be male? So the concept of probability is telling us that, okay, everything that we are doing is based on the assumption. Everything that we are doing is due what? Is due to chance. So that is just the simple concept of probability. Let's say, for instance, now those people that play raffle draw, that they put everything inside one bowl and they roll it. What is the probability that the first one that they are going to pick is going to be yes? What is the probability that the second one they are going to pick is going to be no? So those are the concepts of probability that we are going to, where we must understand, and then we must know if we really want to work on with the what, with the probability. Let's say, for instance, now in a bowl I have like 7 balls, and 2 of them are red, others are white. If they now ask me that, okay, what is the probability of picking the first ball to be red? Now, in the concept of probability, the total number of the red ball that you are having there divided by the total number of what? The total number of all the balls that you are having in the what? In the bowl. It will give you the probability of what? Of picking red. So let me quickly go to the lecture slide so that I can guide us in this concept of probability. So probability is a branch of mathematics that deal with the likelihood of occurring that time, and provide it only predict that is going to occur in this year of 2025. It may be more than that, and it may not be up to that. So that is why we say it is probability. Anytime you are hearing the word, oh, this thing that I'm saying, it is probability, that means that it is not certain. It may occur, and it may not what, and it may not what, it may not occur. So it is all, it is called the uncertainty. So anytime we are measuring the uncertainty, that means that we are using the concept of what, the concept of probability. So now we are going to be checking some concept that is very, very important in probability. Now the first one is the basic probability. The basic probability. The probability of an event A is a number between 0 and 1. I want to quickly state this, and I want us to get it once, that your probability value is from 0 to 1. Is from 0 to 1. That means that you cannot have a probability value of negative. Anytime you are calculating your probability and you are having a negative value, that means that you are wrong. Probability value cannot be negative. And anytime you are calculating the probability value and you are getting 1 point something, if you are getting anything above 1.0, that means that you are wrong. If you are getting 1.1, that means that you are wrong. If you are getting 1.2, that means that you are wrong. So the probability cannot be greater than 1. And let me quickly say this expressly, that the probability that an event will occur, that we are certain that it is only God that can change it, is 1. Example of that, if I ask you now, what is the probability that tomorrow will be Tuesday? Tomorrow will be Tuesday. It's only God that can change it not to be Tuesday. So the probability that tomorrow will be Tuesday will be 1. So any probability that that event is certain, that it is only God that can change it, it is 1. It's taking the probability of what? The probability of 1. Then any event that it is not going to occur, that is not going to occur, it's not feasible that it's going to occur, but it is only God that can make it occur, it is 0. That is, if I ask you that what is the probability that tomorrow will be Wednesday? Tomorrow cannot be Wednesday. So that event is certain that it cannot occur. So any event that is certain that it cannot occur, take the value of probability to be 0. So anytime you are getting the probability of 0, that means that event can never occur. But anytime that you are getting a probability of 1, that means that event is certain that it's going to occur. The probability that an event will occur that is certain is 1, and then the probability that an event will not occur that is certain is 0. That is why the probability takes its value from 0 to 1. Let us get that one right. Now, if the probability is 0, event is impossible. And then if the probability is 1, the event is certain to occur. Please note that it's very, very important. Now, another thing that we normally work on with probability is what we call the sample space. The sample space. The sample space X is the set of all possible outcomes. So it's the set of all possible what? All possible outcome of the experiment. So let me quickly use, I'm going to be using example that you can relate with. I don't deal with abstract, I deal with the real life situation. So I'll be using an example of real life situation. So you don't need to cram anything. You just need to understand the concept. That's all. Now let's say, for instance, now let's say a pregnant woman, for instance, now that want to give birth to just one. I'm not talking about twin now. Now, if I want to ask that, what is the probability that this pregnant woman is going to give birth to a male child? Just a single birth. It's not twin. I'm talking about just one now. Now, we have possible outcome. Is either it is female or male. We don't have female and male. If not for twins, one person to be female and male. That one is a hermaphrodite. So now, the sample space that we're talking about is that we have 2 possible outcomes. The first outcome is either male, and then the second outcome is either what? Female. So that male and female that we have, that is the 2 possible outcomes that we can have when a pregnant woman wants to give birth. Now, that possible 2 outcomes is what we call the sample space. Where you put the 2 possible outcomes is what we call what? The sample space. Can you see my screen, please?
Yes, sir. We can see it.
I've not moved screen. I'm still talking about this.
Yes.
So if I move
I
screen,
can't
you
see
will
the
know.
screen,
I'm still talking
sir.
about the number 2. Can you check
I
your
can't see the
network?
screen,
The
sir.
screen is on.
Oh, I can't see the screen here. I can't see the screen.
I can't see the
It's
screen.
only the title screen.
Can anybody see
So
this
far.
one?
Yes, we can see the screen. Some can see the screen.
You
Though
see
we
the
can see the screen.
You
So
cannot
you
be
can
seen
see
now.
the screen. Some of us cannot.
Scroll up, man. Scroll up.
Please,
Ensure you are on the first stage.
my screen is showing. No, please. The screen is showing. So let's continue. Now, as I was saying, we have just two possible outcomes. Is either male or female. So now, if anybody now asking you, what is the probability that that pregnant woman is going to give birth to male? Now, you will check your sample space. How many possible male do we have? There is just one. So 1 divided by how many experiments that we have. Let me say how many sample. Let me put it like that. How many sample do we have? We have just two. Is either male or female. So that divided by what? Divided by 2. So that is the probability that that pregnant woman is going to give birth to a male. Now, if they ask you, what is the probability that that pregnant woman is going to give birth to a female? How many possible female do we have? It's just 1 divided by our total sample space. We have what? How many elements we have there? We have male and female, which is 2. So the probability that that pregnant woman is going to give birth to a male so the sample space is male and female. Now, if you look at this one,
We can't hear you again, sir.
We can't hear you, sir.
We can't hear you again, no.
Maybe it's
I
an
think it's
system.
network.
Maybe it's network.
Maybe the
It's
network.
network problem.
Maybe it is the network problem. Hope is aware that we couldn't hear him.
It's like it's offline because I can't see the slide again.
oh, sorry, I'm back. Nigeria network. Sorry, please.
You're welcome
So
back,
let's
sir.
continue. Thank you. So you can see my screen now. So let's move on.
I couldn't
So
see it. Oh.
can you see
I
my
can't.
screen?
No, sir.
Yes,
No, no.
sir.
Ah.
We can't
Yes,
see it.
sir. We can see your screen. Let them
Ah.
show up and be on the first page. That's why they are not.
Hey. I couldn't see it. Oh.
That's my judgment. I'll get a link.
I couldn't see the screen. Oh, please. Oh.
I think it's out again.
Ah.
This network is not friendly at all. Ah,
That is one of the probability.
Probability that there will not be network is what?
Yeah.
Is
The
zero because network
probability
will
that
soon
is,
come back.
the probability that is
It's 1/2.
Yes,
It's
it's
either
one over
light
two.
or no light.
Yes. I've been passed already.
At the party, oh. It is well.
Okay, ma, I'm back again. Sorry for the network. So let's move on.
You're welcome, sir.
Yes, ma. So another concept that we use in probability is called independent event. Independent event. What do they mean by the independent event? The reason why I'm giving us all this thing is that by the time we start the calculation, can we mute our mic? By the time we start the calculation, it will be very easier for us. Now, if you are hearing the word independence, so it means that if you're having two events that can occur together, that is, the occurrence of one does not delay the occurrence of the second one. The occurrence of the first one, it doesn't delay the occurrence of the second one. That is what we call the independent. That is what we call the independent. Let's say, for instance, now, if you are having a coin in your hand and then you are having a die. So by the time you throw the coin up, the probability of the coin coming up to be 8 does not is independent of the die that is coming up to be 5. That is for game. Let me use real life scenario. Now, the probability of someone give birth is an independent of someone that is having malaria. So that means that someone that is giving birth does not even have anything relating to another person that's having malaria. So if two events can occur together, that one cannot delay the second one, that particular event, it is called independent event. Now, another event is what we call the mutual exclusive. Mutually exclusive. Then when we are saying mutually exclusive, that means that the occurrence of one prevent the occurrence of the second one. That means that two of them cannot occur together. Two of them cannot do what? Cannot occur together. So anytime you are having a situation or an event that two of them cannot occur together, it is called a mutually exclusive. Another way around that you can know is that anytime the intersection, we're going to be using some little mathematical set term now. Anytime you are hearing the intersection simply means that if you see this sign that look like a cap, it is called the intersection. Anytime you are having the intersection of two events that is equals to 0, that means that event is mutually exclusive. Let me take it again. Anytime the two events, their intersection is equals to 0, that means that event are mutually exclusive. That means that event cannot occur together. That means that event cannot occur together. Another concept that I want us to look at tonight is what we call the conditional probability. We've checked the independent event, we've checked the sample space, we've checked mutually exclusive. So another concept is what we call the conditional probability. The conditional probability means that before an event can occur, it depends on the existing one. What did I mean by that? Let's say, for instance, now, before someone can give birth, it depends on that person must be pregnant. So now the event of pregnancy and birth is conditional. So the condition for giving birth is what? That person must be pregnant. So in that case, we have what we call the conditional probability. If you look at this, the probability of A given B, that is the probability that the A will occur such that B has occurred. So that means that the probability that A will exist such that B has been in existence. So that means that the probability that you are going to give birth such that you are pregnant. So in that case, it is called the conditional probability. So, and then the conditional probability is simply expressed as what? The probability of A intersection B, then divided by the probability of B. this is still looking like abstract. So by the time we get to the calculation part, you will really understand what I mean by that. So now the probability of A given B is the conditional probability. So this is how we normally write the conditional what? Conditional probability. So the probability of A intersection B divided by the probability of B. Anytime you are seeing something like a cap, this symbol like a cap, it is called intersection. And then the other way around, it is normally looking like a cup. It look like a cup. Let's say, for instance, now let me pick my my writing material. Okay, let's say, for instance, if you see something like U, this is the union. So we normally call this one union. This is the symbol for union. But anytime you are seeing something like N, something like N, like a cap, it is called what? The intersection. Now, the probability of A intersection B, this is very, very important. The probability of A intersection B, it simply means probability of A multiplied by probability of B. Now, please let us listen to this. Anytime you are hearing the word intersection, this particular N, the N also is the same thing as the multiplication. It's the same thing as what? As multiplication. But the union, which is U is the same thing as what? The U is the same thing as positive, which is addition. So anytime you are seeing the union is the same thing as what? As addition. Why the intersection is the same thing as what? As multiplication. Can you see my screen, please? Can anybody hear me?
No.
Yes.
Yes, sir. Yes, sir. We can hear you, sir. We can hear you.
Okay, please, I think the issue of network. Let's move on. I think the issue of network tonight is all around. It's all around. So please let us move on. Can you see the slide? Okay,
Yes,
your network.
I can't see the symbol.
Okay, so let's continue, please. So anytime you
The
are seeing
failing slides here, the network.
So anytime you are hearing the word union, they are referring to in mathematics as what? As addition. So it is very, very what? It is very, very important. This is used when the occurrence of one event affects the likelihood of another one. Note, the union in probability is addition. Please note this is very, very important. The union in probability is called the addition. And then the what? The intersection in probability is multiplication. And then the total probability is always equals to 1. Please note that. Now, let's forget about the abstract now. So let's move down to a question. Now, when I was checking your slide, this particular question, I saw it in your slide. And this is the same particular question that was set for the student of public health, I think like 2020, 2022 in UI. Is under probability. So I'm going to, let's quickly look at that and see the way we can move on. Now, look at this question. A father and his son were diagnosed for COVID-19. Consequently, they were taken to an isolation center at the same time for treatment. The case fatality rate of the disease is known to be higher among the older person than the younger one, implying that the risk of dying may be higher for the father than the son. Please let us be taking note of that. Now, this is where we are now going. The probability that the father will survive is 2 over what? 2 over 5. The probability that the father will survive.
This network.
Can you hear me?
Yes.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Okay.
Yes, I can.
So the probability that the father will survive is what? Is 2 over 5. Please let us be taking note of this. Then the probability that the son will survive is 7 over 10. Now the question is now this: find the probability that at least one of them will survive. That is, you know, now the event that we have now is the probability that the father will survive, and then the probability that the son will survive. Now they now ask us that what is the probability that at least one of them will survive? Please note this: the total probability is always equals to 1. Please note that. Now, please also note that the probability of survivor which is the, let me put it as S, the probability of survival, which is S, then plus the probability of dying, which is, let me put it as D, the probability of dying, which is D, okay, is always equals to 1. That means that we cannot have any event that is out of these two events. It's either someone is alive or someone is dead. So that is just two outcomes. So anytime you now have the probability of dying, the probability of surviving plus the probability of dying is always equals to 1, because it is the total sum of probability always equals to 1. You can't have any other event. We can't have someone that is alive and still die. No, you can't. These two events cannot occur together. So that means that you can't be alive and still die. No. So it's that someone is alive or someone is the other way around. So the probability of surviving plus the probability of dying is always equals to 1. Now, from the question now, you have been given that the probability that the father will survive is equals to what? 2/5. Now, what is the probability that the father will not survive? Remember that the total probability that the father will survive plus the probability that the father will die is equals to 1. Now, you have been given from the question that the probability that the father will survive is 2/5. What is the probability that the father will not survive? Just take this probability that the father will die. Sorry. So the probability that the father will survive, take it to the other side to come and meet this one. Then you are left with what? The probability that the father will die. So now, if you look at this second one here, the probability that the father will survive is this, which is 2/5. Then the probability that the father will not survive is going to be 1 minus probability that the father will survive. We just take this guy, this probability of surviving, we take it to the other side to go and meet 1, to go and meet this one. So by the time it's come to the other side to come and meet this one, we're going to have 1 minus the probability that the father will what? The father will survive. So by the time we find out that we're going to have 1 minus 2/5, then by the time you find this, you are going to have 3/5. Now, please note that let me quickly teach you small mathematics here, which is very, very easy, and it is very, very convenient for you. So anytime you are hearing anytime you want to subtract a fraction from 1, anytime you want to subtract a fraction from 1, just do like this. The denominator here that you are seeing here, just say 5 minus 2. 5 minus 2 will give you 3. Write that 3, then divided by the denominator, which is 5. Anytime you are having 1 minus the fraction, just subtract the denominator minus the numerator. You are going to have 3, then put the denominator straight so that you will not be wasting your time during the exam. So that is the fastest way of getting that. So now we've gotten the probability that the father will not survive. Now the next thing is that let us find the probability that the son will not survive. Remember that you have been given that the probability that the son will survive to be 7/10. Now the probability that the son will not survive is going to be 1 minus what? The probability that the son will survive, which is what? 1 minus 7/10. 10 minus 7 will give you 3, then put that 10. So that is how you find your what? If you are subtracting a fraction from 1, just do what? The denominator minus the numerator, you write the value, then divided by the denominator. So we have this. Now, let us now go back to the question. What is now our question? The question now is, what is the probability that at least one of them will survive? That is, out of these two, one will survive. One. Anytime you are hearing the word at least, that means that 2 of them cannot die. 1 have to survive, but the 2 of them can survive, but at least 1 must survive. Now, if you are hearing that, that means that the probability that it's either father will survive, son will not survive, but one person survive. At least 1 will survive. And then let me say this expressly. Anytime you are hearing that at least, let's say for instance now at least 1. So it means that from 1 upward. Please note that it's very, very important. At least 1 means that from 1 upward. So it can be 1, it can be 2, it can be 3, it can be 4, it can be 5. It's just that the minimum that you can get to is 1. That is the concept of at least. So anytime you are hearing the word at least, if they say at least 2, so that means that you are starting from 2 upward. If they say at least 3, that means that you are starting from 3 upward. If they say at least 4, that means that you are starting from 4 upward. Now, at least 2 means that the probability that father will survive, but son will not survive. But at least father survived. We have one person that survived. That is at least 1. It has satisfied the condition. Now, the second one is the probability of son survive, but father die. At least one still survive, which is son. Or the probability that both of them survive. I told you that when you are hearing the probability of at least 1, so that means that it's either one of them survive or 2 of them survive. It's either one of them survive or 2 of them survive. Now, let's say, for instance, now the narrative that was the probability that at least one of them die. At least one of them die. Now, look at this now. It's still the same concept. The probability that one of them will die. That means that out of 2, 1 will die, 1 will survive. Now, or the second one is either son die, father will survive, or both of them will die, because you are hearing the word, or we are saying the probability of at least 1 will die. So that means that it's from 1 upward. Now let us now go back to our question. Is the probability that at least 1 will survive? Now let's look at this. Now the probability that father will survive has been given from the question to be 2/5. Now I told you earlier that anytime you are hearing the word and in probability means multiplication. And in probability means multiplication. That is why we are having times. What is the probability that son will not survive? Remember that from this concept, we have find the probability that son will not survive. The probability that son will not survive is 3/10. We've gotten that from here. So we have what? Times 3/10. So we've done this first part. Now let's move to the second part. Or in probability means addition. That is why you are having positive here. Or in probability means addition. Please take note of that. It's very, very important. Or in probability means addition. Now, the probability that son will survive. The probability that son will survive is 7/10. This is 7/10 that you are seeing here. And the probability is multiplication. That's why you're having this multiplication here. Then the probability that father will not survive, or father did not survive, is 3/5 that we've calculated from the probability here. So multiply by this. Then plus. Hello, can you hear me?
Yes.
Yes,
Yes,
sir.
sir.
Yes,
Sir.
Okay.
Yes,
I
sir, we
hear
can
you,
hear
but
you.
you're
Because
too
I'm
fast,
seeing.
sir. You are too
Okay.
fast, sir.
Okay. We are too fast. We have a lot to cover. That's why we are recording this video, so that when I share you the link, you can go over it and go over it again. If I'm not moving in that momentum, we may not cover everything before the exam. So that is why you have
Thank
your
you,
time.
sir.
That's why I'm recording it. You will get the link and you go over it. You go over it. So sorry for that. I just have to be a bit fast so that we can cover everything that you need to cover for the exam. So I'm still going to give room for question when it is 1 hour. Okay. So now, if you look at this, then the last or means addition. Son survive. The probability that son survive is 2/5, and multiplication, the probability that fathers survive, both of them rather, over 10. Now let us do the simple multiplication here. 2 multiplied by 3 will give us 6. 5 multiplied by 10, we have 50. Plus 7 multiplied by 3, we have 21. 10 multiplied by 5, we have 50. Plus 2 multiplied by 7, we have 14. Then 5 multiplied by 10, we have 50. If you look at them, we have the same, the SCI,
I cannot hear you again, sir.
All of us cannot hear. His network.
You're not the only one, no. I can't hear him again.
Queen of the college.
Young boy. Continue the teaching.
Thank you. Just listen to me.
Sorry, can you hear me?
Yes, sir.
Yes, sir.
I just hearing
We can
you.
hear you,
We
sir.
lost you along the
We are
line.
just hearing you, sir.
Okay. This is the first part. Okay, let me welcome question. Please let me have 2 or 3 questions before we continue.
Good evening,
Okay,
sir.
Bisola, go ahead. Good evening,
Yes,
madam.
yes. Now you're explaining to us about the fraction that whenever we see 1 minus, probably 1 minus any fraction, we should deduct the numerator above the denominator above the numerator. We'll get our answer. What if the numerator is higher than probably the one that was given to be 2/5? 1 minus 2/5. What if it is 1 minus 5/2? Is it possible?
You can't have 1 minus 5/2 in probability, because by the time you do that, you are going to have negative, and probability cannot be negative. You can't have that in probability.
Okay, then 2. If we do not use the method you have been taught on 5 minus 2, how do we subtract 1 minus 2/5? How is it done?
Okay, you are going to find the SCM.
Okay.
The SCM is 5. So 1 in 5 is 5. So that is, you are having 5 minus 5 in 5 is 1. 1 times 2 is 2. So 5 minus 2 will give you 3, and then the denominator is 5.
Okay.
You get that?
Yes.
All right. Okay.
Hello,
Any
sir.
other question before? Please go ahead.
Hello,
Ma.
sir. Is
Please
there
go ahead,
any formula, as we have in other ones, that we can apply to solve this particular this probability? I would say probability of you intersection, things like. Is there formula that we can apply to solve this question?
There is.
Because you didn't use any formula, you are just calculating
I didn't
it
use
like
any
that.
formula. It's just the concept of probability. But I will show you the next slide that I want to show you now. I want to show you another formula that you can use to solve this question. Any other question? Let's move on, please. If you check your slide, this particular question is there, and I don't think they solve it. They didn't solve it. The same thing. They just changed the figure. So please mark this question. Okay. Now look at this. Anytime you are having they ask you to find the probability that 2 of them survive, just use this concept of the union. It's going to be the probability of father union son. The probability of what? Father union son. When you expand this expansion is very, very important, that you must know. It's very, very important. The probability of F union S is equal to the probability of F union probability of S minus the probability of their intersection. Assuming their intersection is 0 here, that means that they are mutually exclusive. Now, after that, the next thing that you have to do is, remember, union is positive. Are we together? Union here is positive. That's why I'm changing this to plus. Minus what? The probability of father intersection son. Now, let us do the expansion of this. Recall that I told you from our first slide or second slide that anytime you are hearing the word probability of P F intersection S, simply means that the probability of F multiplied by the probability of X. So intersection is multiplication. Recall that you have been given the probability of father survive, which is 2 over what? Over 5, multiplied by the probability of what? Son survive, which is what? 7 over 10, which is 14. By the time you do the multiplication, we are going to have what? We are going to have 14 over what? Over 50. We are going to have 14 over 50. So now let's go back to here, to our union here. So if you go back to our union, coming back to our union, remember that the probability that the father will survive is 2 over 5, plus the probability that the son will survive is 7 over what? Over 10, minus the probability of their intersection that we've calculated to be what? 14 over 50. 14 over 50. Now let's find the SCM. The SCM is still 50. 5 in 50 is 10. 10 times 2 is 20. Plus 10 in 5 is 10 in 50 is 5. 5 times 7 is 35. Minus 50 in 50 is 1. 1 times 14 is 14. So by the time we add this one together, 20 plus what? Plus 30, we're going to have 55. Then 55 minus 14. So we're going to have what? 1 over, we're going to have 41 over 50. By the time you do the division here, we're still going to have what? 0.82, which is the same thing as what we got here. 41 over 50, 0.82. Any question, please, before we move to probability distribution?
Sorry, sir. Thank you for the teaching. That second method, I don't understand, though.
Okay.
Then, sir,
which one you don't understand in the second method?
The slide is not showing.
The slide is not showing.
It's too tiny, sir. I cannot even see it.
It's not even
Zoom it. Expand it by yourself. You expand it, man. You expand it by yourself.
You can expand it by yourself.
Your slide is tiny. Please, ma, if your
Just
slide is tiny, kindly expand your slide.
Just-
You can expand your slide yourself if it is tiny.
expand your slide from your side there.
Just zoom it.
Can you see my screen?
Yes, sir.
Yes,
Yes, sir.
Yes, sir. We can see it.
Okay. So that is the first part of probability. Can we have questions, please?
Sir, my question is, this second method, thank you, sir, for the teaching. My question is that second method, why did you have to include the intersection in the formula? And not just, since we are asked to find the probability that both of them survive. Why didn't we just go straight and just do probability of father surviving union, probability of son surviving? Why do we have to include the negative? Is it because they said at least?
That's a very good question. Let me quickly react to that. Anytime you are using probability to open a union, anytime you are using a probability to open a union, it's going to give you the probability of individual minus their intersection, because they want to check whether they have things in common. So anytime you are using union, anytime you are using probability to open union, you are going to find the probability of individual then minus the probability of their intersection.
Okay.
Did you get that, please?
Yes, sir. Thank you, sir.
But anytime you are using probability to open intersection, you just expand it straight.
Okay.
It's very, very important.
Thank you.
Any other question? I want us to finish probability tonight. The reason being that the question that the class rep sent to me, 15 questions, the 14 out of that 15 are statistical inference. They are statistical inference. So statistical inference can take us like 3 days. When I was trying to explain to your class rep. So, and I want us to finish the probability today. If we can finish the probability today and then we start statistical inference, we're going to finish before the exam. So if you have any question, please ask now. If you don't understand it, you can go over the video again, but now you can still ask questions before we move to the probability distribution function. Now I have a question for us. Now, if the question asks you, what is the probability that at least one of them died, or at least one of them did not survive? What will be the answer?
We are going to add
the question again, sir.
They are both survived. We are going to add, you know, that we add the probability that the father did not survive, and we add the probability that the son did not survive. So we will have an intersection of both. That will give us probability that one of them died.
Okay.
The question again, sir.
Let's say the question I asked you that what is probability that at least one of them will die?
Okay.
What will you do?
We'll
That
add
would
it
be
together.
You will do
probably
what?
that if one survives. That means probability of
Probability that
the
one
father
will
survives.
die. One will
At
die.
least
Probability
one will
that
die.
one will die.
So
Yes.
that would be probability that the
You
father
know that
dies and
you know
the
that
son
we add
survives,
you know
or
that we add
probability that
One after the other, Mrs. Moedin, please. One after.
that means the calculation will now be probability that the father survives and the son dies, or probability that the son dies, the son survives, and the father dies. We now open it up. We put the
Or the
parameter.
probability that both of them will die. Or remember I told you that at least means that from that
Okay,
point
that at
upward.
least one of them will die. Oh, okay, yes,
Uh-huh.
there will
So
die.
or
Or
the probability that
probability
both
that
of them
father dies and son
is
dies.
good.
We'll now do the
Good.
calculation.
Now, if you want to use this second method, how will you go about that?
That would now be probability of father dying in plus union with a union union probability that is union probability that the son dies.
Yes.
Minus probability of the father surviving intersection of the son surviving.
You tried. Let me quickly tip in something. Remember that if they ask you that what is the probability that at least one of them will survive, the first formula that you mentioned, you are correct with that. But if you want to go by this formula, that means that you have to go and find the probability that each of them will die. Remember that you are given that the probability that they will survive. So when you subtract probability that they will survive from 1, you will get the probability that they will die.
Yes.
Are we together? From the first example, from here, let me quickly go back there, because it's either they bring it that they survive or they bring it that they die. So they can't bring any other one aside from that. So so that it will not look as if it is only survive that we treated in class. Now, if you look at this now, assuming that we are looking for probability that at least one of them will die, and you are given that the probability that they will survive, first of all, find the probability that they will die. The probability that the father will do what? The father will the probability that the father will die is what? Is 3/5.
3/5.
The probability that the son will die is 3/10. We've established that. Now come back to this second formula. So now, instead of now taking this as the probability that they will survive, now it's not going to be the probability that they will die. What did I mean by that? It's going to be the probability that they will die that you've calculated for this, which is what? 3 over what? Which is 3 over
5.
what?
Over 5.
3 over 5. Then plus
and 3 over 10.
And 3 over 10. Good. 3 over 10. Good. 3 over 10. Then minus the intersection between them is going to be what? This guy, 3 over 5 times. Remember, look at the intersection. Times 3 over 10. So it's going to be what? 9.
6/50, which is
over 50. You get? It's going to be 9 over 50. So by the time you find the SCM is going to be 50. So now 5 in 50 is going to be 10. 10 multiplied by 3, we are going to have 30. 30 plus this one is what? This one is 10. 10 in 50 is going to give you 5. 5 multiplied by 3, we are going to have 15. Are we together? Then minus 50 in 50 is 1. Then 1 multiplied by 9, we are going to have 9. So by the time we add this together, we are going to have what? 45 minus 9 over what? Over 50.
50.
Are we together?
Not clear, sir.
Oh, I'm still going
No,
to
sir.
explain again. I'm still going to explain
Sir,
again.
getting it.
I'm still going to explain again. I'm still going to explain again. So now, by the time you do
Please
this
go over it
subtraction,
again, sir.
He said he will go over it again.
so by the time we do this subtraction now, we're going to have what? We're going to have 30 what?
That's
36.
36.
36 over what? Over 50.
Over 50.
That is the probability that at least one of them will die. Remember that at least probability that one of them will survive is this. Probability that at least one of them will die is this. Now let me go over it again. Please, I will go over it again for the last time so that we can move on, please. So let me go over it again. Look at this question. We are given that the probability that the father will survive to be 2 over 5. And we are given that the probability that the son will survive to be 7 over 10. Now, did I ask us that we should find the probability that at least one of them out of the two, you know, we have two events, the event of father and then we have the event of son. So now they are now asking us that we should find the probability that at least one out of these two events will survive. So now, let us look at this now. Now, we've gotten they've given us the probability that the father will survive. What is the probability that the father will not survive? Remember, I told us that the probability that someone will survive plus the probability that that person will not survive is always equals to 1. It's always equals to 1. So now you have been given the probability that it's going to survive to be 2 over 5. To get the probability that it's not going to survive, just subtract what? Take that 2 over 5 to the other side. We are going to have 1 minus what? 2 over 5. You are going to get the probability that it's not going to survive, which is 3 over 5. Get that one. Now, the probability that the son will survive is 7 over 10. The probability that the son will not survive is going to be 1 minus what? 7 over 10. What? 1 may die. And it's possible that 2 of them will survive. At least 1 will survive. So that means 1 can survive, 2 can survive. If they say at least 1 will die, 1 can die, 2 can die. Are we together? So now, at least 1 will survive means that the first event, the first possible outcome that we can have is that it's either the father will survive and son will not survive. But at least 1 still survive out of the 2. Or it's either the son survive, father did not survive. At least 1 still survive out of the 2. Or 2 of them will survive. That is the concept of at least 1 will survive. Now, looking at this now, what is the probability that father will survive is given from the question to be 2 over 5 from the question. Multiply the probability that the son will not survive. You've calculated that to be 3 over 10. There or in probability means addition. So plus the probability that the son will survive is given from the question to be 7 over 10. Then times the probability that what? The father will not survive. The probability that the father will not survive, which is given to be what? 7 over what?
10. 7
Sorry?
over 5. No, 3 over 5.
Which is given 3 over 5. Good. Which is given to be 3 over 5. Then all means addition. Both of them will survive. That is the probability that the son will survive. The probability that the father will survive is 2 over 5 times the probability that the son will survive, which is 7 over 10. So by the time we do justice to this, it's going to be 2 multiplied by 3. We're going to have 6 that we're having here, divided by 5 multiplied by 10 is 50. Plus 7 times 3 is 21. Divided by what? 10 multiplied by what? 5, which is 50. Plus 2 multiplied by 7 is 14. Then we have 5 multiplied by 10, which is 50. So we have addition. You can find the SCM. The SCMA is 9, is 50 rather. 50 in 50 is 1. 1 multiplied by 6, you are going to have 6. Plus 50 in 50 is 1. 1 multiplied by 21, you are going to have 21. Plus 50 in 50 is 1. 1 multiplied by 14, we are going to have 41 over 50. So which is 0.82. That is the first method. Now let's look at the method 2 before we proceed to probability distribution function. Now, if you look at the method 2, anytime you are hearing that at least one of them will survive, just find their union. The probability of father union son. The probability that the father survives union son survive. And anytime you are opening the bracket of probability when you have the union, it simply means what? The probability of father survive, union, the probability of son survive, then minus the probability of their intersection. The probability of their what? Intersection. So that means that if you are opening the what? The probability of the intersection is going to be the probability of F times the probability of S. Now you have been given the probability of F in the question to be 2 over 5 multiplied by the probability of S. It has also been given from the question to be 7 over 10. By the time you multiply the two together, we are going to have 2 multiplied by 7 is 14, then 5 multiplied by 10 is 50. Now come back to our formula that we're having here. The probability of F is what given from the question to be 2 over 5 plus the probability of S is given from the question to be 7 over 10. Minus the probability
The network is bad.
Very, very good.
We can't hear you again. No, that's
this guy, but we've calculated it to be 14 over 50, which is this. Find their SCM. The SCM is 50. 5 in 50 is 10. 10 multiplied by
Your slide is not showing again.
when
the slide is there.
I cannot even hear him again.
the
Is the network.
Yeah. Mo tọrọ owó lọ́wọ́ ẹ̀ ní ó máa yọ owó bó ṣe wù ú, olóyè òkè. Something àsáré san.
Yeah, Taiwo, mute your mic. Oh.
Ẹ ṣe omi mọ.
Can you hear me now, please?
Yes, sir.
Yes, sir.
Okay.
Welcome back, sir.
Thank you, ma. Okay, so let me share this slide again. Okay, can you see the screen now, please?
Yes, sir.
No, sir.
No, sir.
Please, let's
Yes, we
check
can
our
see.
network. I think that network is a general issue tonight. So let's check our network. Can you see the slide before we continue?
Yes, sir.
Some
We
of
can
us
see.
can see.
Yes, sir.
Yes.
Okay, okay.
Yes,
So
sir.
that is how we come to this final answer here, which is 41 over 50, which is 0.82. So let's move to probability distribution function.
No, before you move, sir.
Okay, ma.
That letter you have said the one that looks like a hen is intersection, meaning multiplication. The one that looks like you, what is it? Oh,
It's union.
what does union?
It's union. Yes. And it is
What does that
addition.
union? What does it
Addition.
mean? Addition. Okay.
Addition.
Thank you, sir. Thank
Addition.
you.
Yes,
Thank you.
ma'am.
Thank you.
Any other question? Okay, let's move to probability. Okay. Oluyomi, go ahead, please.
Thank you. I just want to find out the other one that we're working, that the one of them will die. Is it the total answer is 36 over 50? I just want to find out.
Yes.
All right, thank you.
You're welcome. Okay. So probability distribution function. We also call it PDF. A probability distribution function describes how the probability are distributed over the value of random variable. So I'm going to start my concept with a random variable. Now, all what we have been saying so far, the probability of father die, the probability of father not die, the probability of surviving. Now we want to model it. The concept of modeling the probability is what we call the probability distribution function. The concept of modeling the probability is what we call the probability distribution function. Now, under the probability distribution function, we have what we call the model of probability distribution function is what we call the Bernoulli distribution function, not the binomial now. We started from the Bernoulli. How do we define that? Now, anytime you are having an outcome that is just two, we have two outcomes. Let's say, for instance, now, is that someone is tested positive to a particular disease or negative? The outcome is true. Now, if you perform that test just once, if you perform the test just once, that means that if you want to model that test, it is called a Bernoulli test. But in the real life situation, we perform more than one experiment. So anytime you are performing more than one experiment, and then you are having your outcome to be two possible outcomes, is either positive or negative. Let's say, for instance, now somebody that a family, let's say the husband and wife, that they want to work, they have it in plan that okay, we are giving birth to let's say we are giving birth to four children, for instance now. So how many times do you want your wife to conceive? If it is one times, that means that it's following a Bernoulli distribution, because the outcome of pregnancy, if it is not twin, is either male or female. We have just one outcome. We have two possible outcomes. It's either male or female. But you are trying that pregnancy just one. Now let us now say that okay, you agree between you and your wife that okay, we want to give birth to. I want you to conceive like two times. Now that one is no longer one again, but it's now two times. So anytime you are having the experiment of now giving birth, or the experiment of now conceiving now is now two times. You want her to conceive like two times or three times. So in that case, we now have what we call a binomial distribution. That is why they normally say that a binomial distribution is the end trial of Bernoulli distribution. Everything started with the Bernoulli distribution. Bernoulli distribution is simply just means we have two outcomes, but the experiment is performed once. We have two outcomes, but the experiment is performed once. But anytime you have two outcomes and the experiment is performed more than one, it is no longer a Bernoulli distribution, but a binomial distribution. A binomial distribution, the experiment of the two outcomes must be performed more than one. So anytime you are performing more than one, it is called a binomial distribution. They will tell you from the question that your n is the number of trials, the number of times you perform it. So if they are telling you that your n is equals to 2, that means that you are using a binomial. That means that you are performing that experiment 2 times. If they tell you that your n is equals to 3, that means that you are performing that experiment 3 times. If they tell you that your n is equals to 4, that means that you are performing that experiment 4 times. If they tell you that your n is equals to 5, that means that you are performing that experiment 5 times. That is what we call a binomial distribution. The binomial distribution is the one that common. If you are seeing any question, it's going to be on binomial. But I just want you to understand the concept.
Hello. Hi. We are waiting for him.
Thank you.
When you perform.
Network, borrow Oluwa.
Network, please, so is it only me that is not hearing anything? Is it only me that is not hearing?
It's not only you, man. It's network.
It's not only you, man. Network
Okay.
has logged in.
Not only
I
you,
can't hear
Waka.
you.
Okay. Thank you.
Please, I can't hear anything. No, I don't know if any.
I'm about saying that too.
I can't hear anything. No.
Maybe if the network is okay, if you not ask any question, let it just finish straight.
If people can keep calm and let him just finish, since we can get to view it later, then let them document their questions and send it on the group. Maybe we'll be able to answer. Let's try that method. Let him finish with us at a go. So we don't keep interrupting him.
Yes, that's it now. We have to let him just finish.
Or else we'll not finish this thing.
Probability that it is. Carry the first process. Right? Carry that it is. Probability that.
Olubukola, mute your mic. Mute your mic. Students.
This thing is becoming too prolonged.
Hello, everybody. I think it's a network problem. I can't hear from the lecturer.
Hello, sir.
Hello, sir.
Same here, sir.
It's a network problem, right?
It's general, please. All of
Okay,
us,
Yes,
thank
we are
sir.
you.
not
Yes,
hearing.
sir.
My chief.
How are you, sir?
Ekalesa. I remain loyal, sir.
I remain faithful all the time.
Akushe, you're down.
Queen of the college, where are you?
Young boy. I'm gentle.
Don't sleep, don't sleep. Nobody should sleep.
Statistics is making me gentle.
Hello, I can't hear anything. No.
You are not alone, we are all together.
So you said that we should not leave the class, so everybody just hold on.
Okay, I'm back. Sorry for the network. I know we are going to finish this class tonight. If it is 10 o'clock, we are going to finish it.
Welcome back, sir.
Yeah, thank you, ma. Sorry for that. It's network. Okay, so as I was saying, the probability distribution function, the model of probability distribution function is the Bernoulli, which is just a single trial but two outcome, and then the furthermore is the probability, the binomial distribution, which is the n trial of Bernoulli distribution, that the n must be greater than 1 at the concepts, and then we look at question, how they con question under that. So we have the discrete probability distribution function used for discrete random number. Let's say, for instance, now, let's say the total number of people in this class, it is count. Anytime you're hearing the word discrete, it means count number. Anytime you're hearing the word discrete, it means what? Count number. So let's look at this example. A pair of dice roll, the probability of 1. Like now, if you look at your dice, it has 6 faces. So the probability that is going to show 1. Remember that the first thing is your sample space. In the sample space, we have 1 to 6, which is for the outcome of dice. So now, the probability that is going to show 1 is 1 over what? The total sample size, the total sample space, which is 6. Meaning that the probability of rolling a dice showing 1 is 1 over 6. If I ask you, what is the probability that the die is going to show me 2? How many 2 do we have in a single die? Is just 1, so it's still 1 over 6.
1.
If I ask that, what is the probability that is going to show me 5? How many 5 do we have in just a die? Is just 1, so we are going to have what? 1 over what? Over 6. Now, this is the concept of Bernoulli I'm talking about the other time. So Bernoulli distribution is a model, a random experiment with only 2 possible outcomes: success, usually coded as 1, and failure, usually coded as 0. It is the simplest type of probability distribution. So the only limitation of Bernoulli is that it's just single experiment. It just was single experiment. Now, the binomial distribution the binomial distribution generalize the Bernoulli distribution to multiply trials. That is, your trials must be more than 1 of a random experiment. It molded the number of success in a fixed number of independent Bernoulli trials. So that is, if we are, I told us that the outcome is just 2. The outcome is what is 2. But when you now perform the experiment more than 1, we have what we call a binomial distribution. It's very, very important. Now, look at this. The probability density function of a binomial. I don't know, you've seen this formula before. Maybe from your class, you've seen this before. So this simply means n combination x, then the p raised to the power of x, then q raised to the power of what? N minus x. Now, what is the meaning of all these parameters? N that you are seeing here is the number of trial, the number of trial that you perform. Then the X that you are seeing here is the number of success that you are after. I'm going to explain that. Now, the P that you are seeing here is the probability of success. Success in this does not mean the real success that we are talking about. Your own success may be giving back to a male child. Your own success may be, okay, if I can finish reading my book by 7 o'clock. Your own success may be if I can get home by 7 o'clock. So you define your success yourself. Your aim, your target is your what? Is your success. So now, then the P is the other way around of success, which is Q. Please note that the probability of success plus the probability of failure, which is Q, is equals to 1. Please note that P plus Q is equals to 1. It is very, very important. So now, another thing that I want you to look at here is that by the time you add the power of P here that we have to be X, and then you add the power of what? The power of Q, which is N minus X. If you add the two powers together, it must give you N. It must give you this guy that you're having here. What did I mean by that? The power of what? The power of P is X. This is the X. Then plus, if you add the two together, plus the power of Q is what? N minus X. N minus X. Let me just put it like this. N minus X. So by the time you add these two together, you know this is minus X. This is plus X. This guy will cancel this guy. So if these two cancel, then we are left with what? With N, which is the power that you are seeing here. What I will say in essence is that by the time you add the power of these two together, must give you the what? The number of trial that you have. So we're going to look at questions so that it's going to be clear. It will not look like abstract to us. Now, the N combination X that you are seeing here, this is the expansion of N combination X. The expansion of N combination X, it simply means the what? X factorial, like this hyphen, like this column that you are seeing here. Is it column or exclamation mark that you are seeing here? Divided by what? N minus X factorial, the X factorial. Now look at this. This is N combination X. Let me use numbers so that we can understand. Let's say for instance now, excuse me. Let's say for instance now, I have my N to be equals to, let's say I have my N to be equals to 5, and then I have my X. I have my X to be equals to 3. Let's say I have my X to be equals to 3. Now, to find N combination X now is going to be the 5, N is 5 now. So it's going to be 5 factorial divided by N minus X. It simply means that 5 minus what? Minus 3, which is going to give me 2. So I'm going to have 2 factorial. 2 factorial. Then X is 3. So we have 3 factorial. But your calculator can quickly do this for you. Just press 5 combination what? 5 combination 3. So by the time you do this, the expansion of this, it simply means 5 multiplied by 4 multiplied by 4 multiplied by 3 multiplied by 2 up to the last one, which is multiplied by 0. Now look at this expansion. Let's say we have a 3 factorial. 3 factorial simply means 3 multiplied by 2 multiplied by 1 multiplied by 0 factorial. Please note that 0 factorial is equals to 1 and 1 factorial is equals to 1. So by the time you expand the numerator, you are going to have a value for it. By the time you expand the denominator, you are going to have the value for it. So by the time you do the division, you are going to have a value which is from the N combination X. Let us look at the example so that you can understand. But I just have to tell you all this concept so that when we get to the example, you will not be asking that, okay, where did you get this? How do we get this? Where can we get this? How can we get this? So that's why I have to just put this together so that we can quickly understand this. So let's look at the example. Okay, I've defined this. N is the number of observation. X is the number of success, which is outcome trial. P is the probability of success. Q is the probability of failure, which is 1 minus P. Now let's look at this particular question. So I'm going to give room for question after solving this example. Now look at this. A new vaccine is tested on a population and it is found to be 80% effective. That particular vaccine, let's say COVID-19 vaccine, they've tested it on the population and they discovered that it is 80% what? Active. That is, for any given person who received the vaccine, there is an 80% probability that they will become immune to the disease. Now, anytime anytime you are hearing the concept of disease, let's say for instance now, okay, you are hearing the probability, okay, the probability that, okay, you are given this this particular vaccine to this person is going to be immune of the disease. Now, if you look at this, the first one is the P, sorry. The 80% that you are seeing here is your P. Let me use another color. The 80% that you are seeing here is your P, which is equals to what? Which is equals to 80 over 100. So if you are reading the question, just be bringing out your parameter one by one. Now, suppose 10 people are vaccinated. That is N. 10 people. How many people vaccinated is 10? Which is our N is 10. Are you getting it now? So we have our P, which is the probability that the vaccine will be effective, to be 80 over 100. Then we have the probability. How many people did they vaccinated? So they vaccinated 10 people, which is N. So we have our N to be 10. Now, let us now go to the question. What is the probability that exact 8 out of 10 we exact 8 out of 10 become immune? What is the probability? So now, the one that you are asking to find now is now the X that we want to get. The X is the question that they ask us to find. What is the what? What is the probability that exact 8? So our X is 8. Exact 8 out of 10. So that means that if you vaccinate 10 people, what is the probability that out of that 10, 8 will be immune? They didn't say the probability that all of them will be immune. 8 will be immune. So that means that our own concern now is that we want to find the probability that, okay, let's say we are picking a sample of 10 and then we give them the vaccine. 8 out of 10 will be what? Will be immune. So now let's quickly look at the solution. Now look at this. The number of trials is 10 since 10 people are vaccinated. The probability of success, which is P, is a what? Which is 0.8, which is 80% effectiveness. Now, the probability that that vaccine will not be effective, remember that the probability that it's going to be effective plus the probability that it's not going to be effective is equals to 1. Now, the probability that it's going to be effective is 0.8. Then plus the probability that it's not going to be effective, which is Q, is equals to what? Is equals to 1. Now, to find my Q, just send the what? The 0.8 outside. We're going to have 1 minus what? 0.2, which is the one that we're having here. Which is the one we're having here. So now we've given from the question, they've given us our what? Our P, which is the effectiveness of the vaccine, to be what? To be 80%, which is 0.8. Then our Q now is now 1 minus what? 1 minus 0.8, which is 0.2. So you have been given 0.2. Now, since we have the first thing that you have to establish here is that now we now have two outcomes: the effectiveness of vaccine, or the vaccine is not effective. That is two outcomes. Then how many times do we perform? How many people do we vaccinate? We vaccinated 10 people. So your N is equals to 10. So anytime you are having this, remember I told us that when you have two possible outcomes and your N is greater than 1, starting from 2, it is binomial that you are going to use. So in that case, this particular word, this particular question, we follow what we call a binomial distribution. Then the formula for binomial distribution is this. You have been given N. N is equals to 10. 8 is the one that we want to find. Exact 8. That's our X. Then the P is the probability of effectiveness of the vaccine, which is 0.8. Then X is given to be 8. Then Q is 1 minus 0.8, which is 0.2. That is the probability that that vaccine will not work. Let me put it like that. The probability that that vaccine will not work. Now, our N is 10, then minus 8. By the time you add 8 plus 10 minus 8 together, which is the power of these two, this P and Q, it will give you 10 back, because 8 minus 8 will cancel, then we are left with 10. So now let us now come back to this. Then exact 8 means that we have 10 combination 8. Then we have our P is 0.8. Our X is 8 raised to power 8 multiplied by our Q is equals to 2. Then our N is 10 minus our X, which is 8. How do we expand this? Now look at this. From our knowledge of combination, this one becomes 10 factorial over 10 minus 8 factorial, then 8 factorial. Then multiply by the time you find 0.8 raised to power 8, you are going to have this value. And then by the time you find 0.2 raised to the power of 2, 10 minus 8 will give you 2. So 0.2 raised to the power of 2, you are going to have 0.04. Now, let's move to the next line. The next line is, let's expand this 10 factorial. 10 multiplied by 9 multiplied by 8 factorial. The reason why I'm going to give room for the question, the reason why I stopped at the 8 factorial is that by the time if you look at the denominator here, I'm also having 8 factorial from our formula. I'm having the 8 factorial. The reason why I stop at 8 factorial is that so that this 8 factorial, we can cancel the 8 factorial, denominator 8 factorial, we cancel the denominator 8 factorial. Now, after doing that, 10 multiplied by 9, we're going to have 90. That's why you are seeing 90 here. Remember that 2 factorial simply means 2 multiplied by 1 multiplied by is 0 factorial. And remember that I told us that the 0 factorial is 1. So automatically 2 multiplied by 1 will give you 2. 2 multiplied by 1 will give you 2. That is why we are having that's that's why we're having 2 here at the what at the that the multiplication of these two guys here, we're having this. So by the time you do justice to this one, 2 here 1, 2 here 45 multiplied by this number, we are going to have this value. So this is going to give us 0. To 3 decimal. This one is going to give us 0.2. This is the probability that the vaccine will what out of the 10 that they vaccinated, 8 will be immune. So this is the probability. Please, let's give room for question 1 or 2. Okay,
sir.
Sola, you can go ahead with your question.
Yes, sir. Good evening, sir. Yeah, you said that the formula that the Q raised to power n minus x, whatever that if x is subtracted from n minus x, you must get the same answer back with the n. Now, if that is done, are we still going to
when n is not subtract, you will add the two power together.
What I'm saying is that when we subtract n minus x, that is the Q raised to power n minus x, when it is subtracted, we will add that answer with p raised to power x. Whatever answer we get, there must be the same with the n inside the brackets.
No.
Do you actually get my answer, sir?
You will add the answer that you have. I'm trying to get you. When you add the power of q minus
when we add the power of p raised to power x
n
plus q raised to power n minus x, whatever answer we get must be the same thing with the n
value that you
can you hear me, sir?
Have at that power n minus hair, so it must give you the n.
Yes.
I can hear you.
So,
I can hear you. Can
okay,
you
now,
also hear me?
yes,
Go
I
ahead.
can hear you now. Now my question now goes towards that. I feel that if we have actually done that, if we have actually done that part, do we still need to add those figures again for our calculations? Like the one that was written 10 all over 8 in bracket, then 0.8 raised to power 8 times 0.2 raised to power 10 minus 2. Do we still need, since we have done the calculation earlier, do we still need to do it again? Do you get my question, sir? Do you understand my question, sir?
Combination.
Maybe we should allow him to finish first before we ask questions, because the network is bad.
We cannot allow him to finish. We are not getting it. We said we should allow him to finish.
He was the one that even said people should ask questions. He said it.
Is there that question? No, better.
Please go ahead with your question. The last speaker, please. Can you ask the question back? The last speaker, please.
Yes, sir. I said that the n all over the n and the x in brackets.
The n
then
combination x. The n
yes,
combination x.
okay, the n combination x in brackets. Then we now have p raised to power x. Then we have q raised to power n minus x. Then for us to confirm our figures, we said that n minus x, if added with x, the answer we get must be n.
Yes, you are correct.
Yes.
Go ahead.
Okay, fine. Now my question goes towards that. If we are able to get that, do we still need to put figures like 10 intersection 8, the one in brackets, then 0.8 raised to power 8 times 0.2 raised to power 10 minus 8? I thought we've already dealt with the 10 minus 8 and 8 0.8 raised to power 8 earlier.
You've not.
Okay.
The reason why I just said that is that, you know, in mathematics, there is a way you can be checking your work as you are moving so that you will know that you are right. By doing that, that does not mean that you've solved the question. You've not. So just for you to check yourself that, okay, I've put the right parameters inside my formula. So by the time you add the two together and you discover that it's greater than the n or it's not equal to the n, that means that you have to go and check those parameters before you move on, so that you will not get to the last final and then you not discover that what you are inputting in is not correct. So that one is just for you to quickly cross check. That means that you've not even solved the question, but just for you to be assured that the step that you are taking is correct. Did you get that, please?
Okay, sir. Yes, sir.
Okay. Please, other question. Any other question before we continue?
Yes, sir.
Please go ahead
Yes,
with
sir.
your question.
Okay. That 10 combination 8, when you opened it, was it the opening that you replaced with 10 factorial?
The opening is we have both the numerator and denominator. The opening is this. Can you see my mouse?
Yes, sir.
The opening is the entire this that you are seeing.
I can't see your slide though.
You can't see my slide.
I can't.
Okay. So by the time you do this opening, the n combination 8 is 10 factorial over 10 minus 8 factorial, 8 factorial. So the expansion of 10 combination x is the one giving us here. This particular this particular guide that we're having here. This particular figure. So is the expansion.
So okay, sir. So does it mean that that factorial thing is a constant? Like when we have 10 anytime we have an equation, like when we are using that formula, so does it now mean that this 10 combination 8, well, by the time we are opening it, we will now have 10 factorial over 10 minus 8 in brackets
Factorial.
8 factorial?
Yes.
Is that a constant whenever we want to?
That is the rule of expanding the combination.
The rule of expanding combination.
You can pick any n. Let's say your n is equals to 20, and 20, then your x is 10. You can have 20 factorial.
The same approach.
But the only condition is that your x cannot be greater than your n. Your x cannot be greater than
n.
Your n.
Okay.
Did you get that? But your n, your n and x can be equal.
Okay, but x cannot be greater.
Cannot be greater than n.
Okay, then my last question, sir. While you were doing the factor, my understanding of this factorial thing is that you will be multiplying in descending order till you get to 0 factorial.
Yes.
Which is 1.
Yes.
So now when you were doing it for 8, when you were doing it for 10 factorial, you said you stopped at 8 factorial because there is 8 factorial as the numerator, as the denominator.
Yes.
So does it mean that once you are doing the descending order for the multiplication of the factorial, the moment you get to a point that you have a factorial reflecting at the denominator, you have to stop.
But yes, you are right. The reason being that if you expand 8 factorial, you have 8 times 7, 8 times 6 up to the what's it called?
Factorial.
0 factorial, which is 1. If you expand this 8 factorial that you're having at the denominator also, you have 8 times 7, 8 will cancel 8, 7 will cancel 7, 6 will cancel 6, 5 will cancel 5.
Okay. So 8 factorial can automatically cancel 8 factorial.
Cancel 8 factorial. So 7 factorial can cancel 7 factorial. 6 factorial can cancel 6 factorial.
All right, sir. Okay.
Please, sir. I have a question, sir.
Please go ahead.
Please, sir, what's the meaning of this factorial that you have mentioned?
Factorial is the multiplication of number in descending order. And then it is
factorial.
Factorial.
Okay.
That is exclamation mark.
Okay. Okay.
Any other question?
No, sir. Thank you, sir.
Yes, sir. There is, yes, sir. Sorry, sir. My own question here is that from this 10 factorial all over 10 minus 8, then we now got our 8 factorial. Was it that 10 intersection 8, the one for n and x, is that the one that is the denominator, or it is the one that is the numerator?
I didn't get your question, ma.
The 10 intersection 8 in brackets, then we now have 0.8 raised to power 8. I now said, is it that 10 intersection 8 that is 10 factorial all over 10 minus 8, the denominator?
We don't have intersection. We have 10 combination 8.
Okay, sorry, 10 combination 8.
Please, continue your question.
Okay, yes, and I said, is it that 10 combination 8 is the 10 factorial up all over 10 minus 8, then we now have 8 factorial.
Yes. Yes.
Then okay, sorry, please. Is it
Right.
is it the 0.8 raised to power 8? Where is the answer to that one?
The answer to that one is 0.167777216.
Okay, times 0.2, then 10, then that 0.2 will be 0.2 times 0.2 raised to power 2.
Yeah,
Where
which
is the
is
answer to that
0.04.
one?
Which is 0.04. This is it.
0.04.
But it is not in it. Okay, times 0.04. Okay.
Yes, hello, sir.
Yes, ma'am.
Please, sir, how did you get that multiplication? You said that the other time that we can even use our calculator
Yes.
to do the multiplication of 0.8 factorial 8. I don't know how to come about that.
You can use your multiplication. You can use your calculator to do that. Let's see, tomorrow maybe I will do a video on calculator, how to use calculators for combination and permutation, how to use this combination factorial of 18, so that I will put it so that you can watch it, because there's no how I'm going to use my calculator to do that now that you will see.
Yes.
So I'm going to do that tomorrow, how to use calculator for factorial, how to use calculator for combination. Then I will put the video so that you can go and check it and use it.
Then hello, sir, concerning the calculator.
Yes.
Concerning the use of calculator, is there a specific calculator that we can use for this?
Yeah, there is. Where's my calculator?
Please, let's know the type of calculator.
I've sent a video that you can check. That one is how to use calculator for probability.
It was sent to the group now.
So please check. That calculator is okay, because we are still going to be using that calculator to get probability value when we get to normal distribution.
Okay, sir.
Yes. So please, someone is typing on the chat box. Can you ask the question? So let us hear once. So your X is the value that you are given that they want you to find. Please note that. Now let's check the second question. Don't worry, we are going to cover everything tonight. So thank God that we are doing the recording. So if you cannot meet up with the class, then you go and watch it again. Now let's look at the second one. What is the probability that fewer than 6 become immune? Fewer than 6. What did they mean by that? Please.
5, 4, 3, 2, 1.
5,
4,
3,
5, 4, 3, 2, 1, 0.
Good. 5, 4, 3, 2, 1, 0. Good.
Oh, yeah, okay.
Can you see now? So that means that X is less than 1. It's less than 6 rather. So that means that we are starting from 0. Remember that the one we just finished calculating is when X is equals to 8. So now it's not going to be when X is equals to 0 plus when X is equals to 1 plus when X is equals to 2 plus when X is equals to 3 plus when X is equals to 4 plus when X is equals to 5. That is what they asked us to find. Now look at me now. Look at my expansion. Look at the expansion. Can you all see my screen?
Yes, sir.
Okay.
Yes, sir.
Now look at my expansion. I started from when X is equals to 0. We have 10 combinations 0 because X is 0. Then the value of the P from the question is 0.8. Then raised to the power 0 because X is 0. Then times 0.2 n minus 0. That is 10 minus 0, which is 10. That is for the first expression. Plus 10 combinations equals to 1. Then we have 0.8 raised to the power of 1. Then we have 0.2 raised to the power of 9. You know the reason why, you know how I got my 9? 10 minus.
Yes, 1. Yes, 10 minus.
So because by the time you do 9 plus 1, you will still have this 10. By the time you do 10 plus 0, you will still have this 10. That is what I was saying the other time. Now, 10 combination 2 is 0.8 raised to the power 2 times 0.2 raised to the power 8. 2 plus 8 will still give you 10. Plus, when s is equals to 3, we have 10 combination 3, then we have 0.3 raised to the power of 0.8 raised to the power of 3 multiplied by 0.2 raised to the power of 7. 3 plus 7 we still have 10. Then plus 10 combination 4, which is 0.8 raised to the power of 4 times 0.2 raised to the power of 6. 4 plus 6 will still give you 10. Plus the last one, 10 combination 5, which is 0.8 raised to the power of 5, 0.2 raised to the power of 5. 5 plus 5 will still give you 10. Any question about that one? So let's move on, please. So now, by the time you do this, 10 combination 0 is 1.
Sorry, sir, your screen is not showing again, sir. Better now. Thank you.
So, as I was saying.
Hello, sir.
Yes, sir.
So any number combination 0 is 1. It might not even be 10.
Yes, sir. Yes, sir.
It's okay.
Yes, sir. So
okay, any number combination 0.
Any number combination 0 is what is 1. What is the meaning of that? Let me quickly explain that, so that don't let me assume that everybody we just get it like that. So that means that 10 factorial over 10 minus what? Minus 0 factorial, there is 0 factorial. At the end of the day, we are going to have 10 factorial divided by 10 minus 0 is 10. So we have 10 factorial. 0 factorial is 1. So that means that at the end, we have 10 factorial over 10 factorial.
It's 10
so
over 10.
Factorial will cancel 10 factorial out. So we have 1. So multiply by anything raised to the power of 0 is 1. Then 2 raised to the power of 10 is this. Plus 10 raised to the 10 combination 1 is 10. So any value that you have combination 1 will give you that value back. That's another theorem. If it is 20 combination 1, it's still 20. If it is 50 combination 1, it's still 50. Please note that it's very, very important. Then 0.8 raised to the power of 1. This one should give us 0.8, not 8. 0.8. Then we have 0.9 raised to the power of 9. We have this value. So the same thing go for the rest and the rest and the rest. So at the end of the day, we have the probability to be equals to 0.00407. That is for the question 2. Let's move to the question 3.
Sorry, sir. Question.
Yes, ma'am. Go ahead.
Sir, when you open that bracket, is when you have that 1 times 1 times 0.0000124. But what I don't understand now is this. After that bracket, there's 0.8 raised to power 9 and 0.2 raised to power 10. Did you multiply the two to get this 0.000?
If you look at that, something that exists between them is the multiplication. So that means that 10 combination 0 multiplied by 0.8 raised to power 0 multiplied by 0.2 raised to power 10. So this is giving me 1. This one too is going to give me 1. Then 0 raised to power 10 is going to give me this value. Is that clear, please?
I did not get it, sir.
You did not get it, sir. Ma. Okay, let me take it again. 0 combinations, 10 combinations 0 is this 1 that you are seeing here. Did you get that 1, ma? Did you understand that 1?
I don't know how you came across the 1 after seeing 10 here.
Okay, let me do it like this. 10 factorial. Do you understand the concept of factorial?
Yes.
Okay. Now, anytime you are having 10 combination 0 is 10 factorial divided by 10 minus 0 factorial, then is 0 factorial. Did you get that, ma?
I'm trying to
Hello, please, I
understand.
come again, sir.
You can continue,
No,
sir.
sir.
You have 10 combination 0. Let me quickly go back. Let me show you what I'm saying. Let's say, for instance, we have 10 combination 0 here instead of 10 combination 8. Please, let's look at this. Now, it's going to be 10 factorial divided by 10 minus 0 factorial, then 0 factorial.
Okay.
Now, 10 minus 0 will give you 10. Remember that we have the factorial here. So it's going to be 10 factorial. Then is 0 factorial will give you 1. So I'm having 10 factorial at the denominator, 10 factorial at the denominator. They are going to cancel out. At the end of the day, I'm going to have 1 over 1 times. Remember that 0 factorial is 1.
1, yes.
So 1 times 1 will give you 1. So we have 1 over 1 will give you 1. That is why we have 1 here.
Okay.
Are you with me now?
Yes, now I understand now, sir.
Oh, good. So we can move on. So the same thing goes for this. Anything raised to the power of 0 will give you 1. Okay. So it's continue like that.
Hello, sir.
Yes, sir.
Hello, sir. Please, can you reverse that side? I'm sorry.
Okay. Which part, sir? Is it
Sorry.
anything raised to the power of 0?
The one you have just mentioned now, 1 over 1 or what?
Okay. 1 over 1 is 1.
Yes.
So when you divide 1 divided by 1 is 1.
I know.
Okay.
Okay, you re-explain the 10 factorial 0, Avi?
Yes.
Okay, I didn't know. Sorry.
Okay.
I understand.
Okay. So let's move on, please. Now let's take the third question. The third question is, what is the probability that at least 4 people immune? What will be our X? Our X will start from where?
From 4.
4 to 10. 10.
4 to 10. Good. 4 to 10. Do you know that we can? Do you know that there is another way around that you can still get it without moving to 4 to 10?
Okay.
Now, remember that the sum of the probability is equal to 1. Please always put that one in your mind. The sum of the probability is equal to 1. Now, the probability of at least plus the probability of at most is equal to 1. Sum of the probability is equal to 1. Whether it's the probability of success plus probability of failure is equal to 1. Whether the probability that someone survives plus the probability that that person will not survive is equal to 1. The probability of at least plus the probability of at most will equal to 1. Now, instead of you now going from 4 to what? To 10, you can quickly calculate when this probability is equal to 0, probability is equal to 1, probability is equal to 2, probability is equal to 3. Then you will subtract this from 1. Final. Let me take that on again. Instead of you starting from 4, 5, 6, 7, 8, 9, 10, you can calculate for probability of 0, which we have calculated from the second, from this Roman figure 2. That is why they are bringing this Roman figure 2 first, because they know that you will need it in Roman figure 3. Now, once you get for probability of when x is equal to 0, add it to when probability of x is equal to 1, add it to when probability of x is equal to 3, then subtract it from 1. Is going to give you at least 4. Let's look at it. Oh, I did not even solve it. I think I left it for them to solve. I think I left it for them to solve. So now this is what I'm saying. When x is equals to 0, we have 0 points. This is the first one. When x is equals to 1, we have this. Can you see my screen, please?
Yes, sir.
Okay. When x is equals to 2, we have this. And when x is equals to 3, we have this. So we are going to add this. Let me put something there so that we can know. So we are going to add 0, 1, 2, 3 together. This one. We are going to add this together. Once you add this together, subtract it from 1. It's going to give you at least 4. This concept of at least is very, very important, because when we get to Poisson distribution, Poisson don't have end. Poisson is at infinity. Poisson is at infinity. So if you are saying at least, that means that you are going to infinity, and you can't get to infinity because infinity is a large number that you can never imagine. It's only God that is bigger than the infinity. So the concept of at least and at most, you knowing that you can add the smaller one together and subtract it from 1 to get at least, because at least continues. So just add this and this and this, 0 plus 1 plus 2 plus 3 together, subtract it from 1, then you have at least 4. Any question on that before we move to Poisson distribution?
So, sir,
you can ask your question now, please.
So let's, from your explanation now, that with reference to that second question says at least 6 will be immune. So let's say the question states that at least 5 will be immune. That means we'll take it from 5 downwards to 0. If the third
At
question
least,
now...
Wait, man. At least 5. You will not take it from 5
No,
down.
no, sorry, less than
4.
6. No, less than 6. Yes, I meant less than 6. So let's say that question says, okay, as that question says less than 6, agreed. If with reference to question 3 now, let's say question 3 now says we should find the probability that at least 4 will be, at least 5. Okay, that's what I can say. At least 5 will be immune. So does it now mean that we will find the value for up to less than 5, and then whatever the value now gives us from 0, 1, 2, 3, 4, 5, we'll now subtract from 1? Hello, sir. Hello.
I'm trying to move this
Good,
person that
Ola,
is
can you move
us.
your mic?
Okay. So you are right, ma. You are right, ma. If the question says at least 5, that means that you are going to add 4 down to 0. So practice from 1.
Okay.
The reason why I want you to know this concept of at least is that when you get to Poisson distribution, that is what you will be using, because Poisson is a very big number that you cannot get to.
Okay.
Yes.
Thank you, sir.
Yes. Please, any other question?
Sir, what did you call it? Is it Poisson?
Poisson.
Okay, sir. Thank you.
Mute your mic, Unico.
Please, sir, I cannot hear you, sir.
It's everyone. Seems the network is gone.
Don't even raise your hand. Your lecturer is offline.
I'm not offline, I'm online. So
Well done, sir.
let's continue.
Global
Let's
time.
continue. Don't worry, you are going to get the
Sorry.
network. I want us to just, we must finish probability today. Don't worry. So if you want to go and rest, you can go and rest. You still come back to the lecture. We are going to finish the probability today. So let's continue, please. We move to the Poisson distribution. So now, let me quickly say this. This is the identity of Poisson. How will you identify that this particular question is a Poisson question? Number one is the concept of rare disease. Anytime you are hearing rare disease, we normally use Poisson to model disease. We normally use Poisson to model disease. It is very, very important. Now, anytime you have the probability, hey, this is my brother tonight. Anytime you are hearing the probability, you are given a probability that is very, very small, and then your sample size is large. Let's say you are given a probability to be, let's say 0.002, and you're having a large sample of 2,000. Are you going to be doing 2,000 combination 5 or 2,000 combination 8? So anytime you are having a small probability value and your sample size is big, you will use Poisson. Anytime you are hearing the word rare disease, or anytime you are hearing the word disease means affecting people, then you will use Poisson. Those are the two identity of Poisson. So once you notice that, that means that you are going to model that question with Poisson. That is for that. Now let's quickly go to that. The Poisson distribution is the probability distribution that model the number of events.
We cannot see your slide anymore.
Check your slide. Check your phone.
The Poisson distribution is a probability distribution that models the number of events occurring within a fixed interval of time or space, where this event happen independently of each other, and the rate at which they occur is constant. It is particularly useful for modeling rare events or count of events over a certain period of area. Just note that we use Poisson to model rare events or disease or the count events. So now, the key characteristics of Poisson: discrete distribution. Poisson is discrete. I've told us that anytime you're hearing the word discrete, it means count. And then in probability distribution, we have discrete and then we have continuous. So we are still checking the discrete. Discrete is the binomial, discrete is the Poisson distribution. So the Poisson distribution only take integer value 0, 1, 2. When you see this dots, it means that it's continuous to infinity. So Poisson has no end, it's continue to the infinity. The reason being that, let's say for instance, now there is an outbreak of disease. You don't know the number of people that disease will affect at that particular time. You cannot predict, but we normally use Poisson to model so that you can catch up with the number of possible people that can be affected by that disease. So that is why we normally make use of Poisson to model a disease, rare disease. Okay, now rate of occurrence, the average number of occurrence denoted as lambda. So the parameter of Poisson is lambda. Remember that the parameter of binomial, please note this, the parameter of binomial is NP. The number, the N is the total observation, the P is the probability of success. They can bring that out in your objective. The parameter of binomial is NP, while the parameter of Poisson is lambda. Note that, it's very, very important. Now, one of the good property of Poisson is that the mean is equal to the variance. So that means that the lambda is equal to the lambda is mean, the lambda is also a variance. Please note that, it's very, very important. Now, the Poisson formula is this, which I would love us to look at this very well. We have the exponential minus lambda, then we have lambda raised to the power of x over x factorial. Let me take it again. Exponential minus lambda, then lambda raised to the power of x divided by x factorial. Then what is x? X starts from 0, 1, 2, 3, it goes to infinity. So if they now ask you that, what is the probability of at least 3 for Poisson? Are you going to start from 3 and you continue going to infinity? It's not possible. So that means that you have to calculate for 2, you calculate for 1, you calculate for 0. Well, every time you add them together, you subtract it from 1. It's going to give you at least 3. So it's going to give you the one that you can get at infinity. So that is why the concept of at least is very, very important, and it's very, very useful in what? In modeling Poisson. The x is the number of events, non-negative. So that means that your x cannot be negative. Lambda is the average number of events per interval rate. The E, that E that you are seeing exponential, is the Euler number. We call it Euler number, which is approximately to 2.71828, which is your exponential. So note, this is very, very important. When the probability of success, which is P, is small, I've said it the other time, and we have a large population, which is your N, the binomial is approximately to Poisson. They can ask you in the objective, what condition can make you approximate binomial to Poisson? Is 2 conditions. Your P must be small and your N must be large. Your P must be small and your N must be large. Then the lambda is going to be NP. Lambda is the parameter of Poisson, while NP is the parameter of binomial. This is very, very important. So let's look at question. The National Health Insurance Scheme is considering of starting a policy for an ailment. Ailment is a disease that affects 0.2%. That is 0.2 divided by 100. It's very, very small of the population. If a random sample of 2,000, the N is large now. Don't think of using binomial. Because if you look at this small, if I look at this P, the P here is very, very small. 0.2 divided by 100 is going to give us 0.002, which is very, very small. And then the sample size is large, 2,000 of individuals selected. Find the probability that at least 3, you see now, at least 3 will have an ailment. Now, if you look at this now, the first thing you have to get the parameter of what? Of Poisson, which is lambda. Record that the probability is 0.2%, which is same as 0.002. Then your N is equals to 2,000. And remember that anytime you have the small sample size, anytime you have the small P, and then you have the large sample size, your Poisson is, your binomial is approximately to Poisson. That is, your lambda is equals to the MP, which is the product of the sample size, and then the probability of the success, the probability that the disease is going to affect the population. So in this case, we have 0.02, which is this P, multiplied by 2,000. Then your lambda is equals to 4. So we have our lambda now to be equals to what? To be equals to 4. I'm still going to give room for questions. So let's continue, please. Which is equals to 4. So by the time we move now, record that at least 1, at least 3. They ask us to find at least 3. At least 3 means that from 3 upward. So which is the same thing as 1 minus the probability of finding x less than what? Less than 3, which is 1 minus the probability of when x is equals to 0 plus the probability of when x is equals to 1 plus the probability of when x is equals to what? 2. Now, look at this now. 1 minus exponential, our lambda is 4. Remember from the formula of our Poisson. Our Poisson formula is what? Our Poisson formula is lambda exponential minus lambda. Now, from our question, we've calculated our lambda to be equals to 4. Then our x is what? Is 0 for the first one, because we want to find at least 3. So we are starting from 0. So now we have exponential minus 4. Lambda is 4 times 4, which is the lambda, raised to power x. X is 0 now. Then divided by the 0 factorial, which is x, plus we are going for 1 now. It's going to be exponential minus what? Minus 4 multiplied by 4 raised to the power of 1, then 1 factorial, plus the second one now is what? Exponential minus 4 multiplied by what? 4 raised to the power of 2 factorial. Furthermore, we have, which is equals to 1 minus, by the time you multiply the 4 factorial, the 4 raised to the power 0 is 1. Exponential minus what? Minus 4 will give you this value that you are seeing up. Then 0 factorial is 1. That's why we have the denominator here to be 1. Plus the exponential minus 4 is still this guy. Multiplied by the 4 raised to the power 1, it will give you 4. Divided by 1. 1 factorial is still 1. Plus exponential minus 4 will give you this guy again. Times 4 raised to the power of 2 is what? 16. Divided by 2 factorial is 2. By the time you do justice to that, this divided by this, we're going to have this guy. Then 4 multiplied by this divided by 1, we're going to have this value. Then 16 multiplied by this divided by 2, we're going to have this value. Then 1 minus, if you sum everything here together, we're going to have this, which is equals to this. This is the probability of at least 3 will be affected by that ailment. So this one has covered for those at infinity. Ask your question now, please. Please
Sir,
ask your question now.
yes.
Please go ahead.
Thank you, sir. When you were opening the formula, when you were trying to substitute the parameters, each of the counts, the 0, 1, 2, why didn't you do for 3? Why did you stop at 2? Knowing that the question says at least 3. I think we should have included 3 and not stop at 2. Why did you stop
No,
at 2, sir?
if you are saying at least 3, it's saying that from 3 upward. From 3 upward.
Sorry.
So after you pick 3, what will you have left for the lower one? It's 2, 1, and 0.
Okay.
You get, so anytime you're hearing the word at least, it's starting from that number upward.
Upward. So you consider those less than the number.
Less than. Good.
Oh,
Are you clear with that, please?
yes, sir.
Good. Let's have another question. We are still going long way tonight. Let's continue.
I don't understand Poisson.
It's not poison, it's Poisson. You don't understand Poisson. Which one you don't understand there? You can't say you don't understand everything. Which one you don't understand there?
How you got those figures when you were inserting those figures into the parameters?
Which of the figure? Be specific.
You know that you were actually dealing with answer number 3, that at least 3.
Okay.
So I should just say that probably number 3 answer was not actually clear to me.
Okay. Which part? Is it the part of getting at least? Is it the part of 1 minus the probability of 0 plus the probability of 1 plus the probability of 2, or the substitution part?
From the probability of getting 0, 1, 2, 3 to 5.
Let me start from there again. But you understand the one of binomial, at least for binomial. Do you understand that one?
I understand it too.
Okay. No problem. Now, anytime you are hearing the word at least, from that number that they mentioned, you'll be going up. If it is at least 4, you are starting from that 4 upward, 5, 6, 7, 8, 9, 10, like that. if they are saying at least 6, that means you are starting from 6 upward. Now, in the case of Poisson, the at least means that you are starting from that number to infinity, and you can't get to infinity. You can't get to infinity. So in that sense, we normally calculate the number that is less than that number that they mentioned, that it is at least, like the one that we have here, at least 3 means that from 3 to infinity. Can you calculate to infinity? No. But you have the power to calculate from 0. You have the power to calculate when it is 0, when x is equal to 0, when x is equal to 2, when x is equal to 1. By the time you now calculate that, you add them together. Remember that the probability of at least plus the probability of at most is equal to 1. Note this. The probability of at least plus the probability of at most is equal to what? Is equal to 1. So by the time you added you add the probability of 0 plus the probability of 1 plus the probability of 2 together, subtract it from 1, it's going to give you the probability of at least 3. At least 3. So now, how do you get the probability for 0? Anywhere you are seeing x, put 0. Remember from our formula, where is the x? Let me quickly go to that formula again. If you look at the formula here, our x is at the what? At the power of what? At the power of lambda. And our x is at the denominator with the factorial. So anywhere you are seeing x, put 0. That's the condition 1, when x is equal to 0. Then we've calculated our lambda to be equal to 4. Then the exponential, you can get it from your calculator, or you use the value that I put there for the exponential. So by the time you do that, the exponential minus 4 is this value, 0.0183156. That is exponential minus 4. Then 4 raised to power 0 will give you 1. 0 factorial will give you 1. I've stated that initially, that 0 factorial is 1, 1 factorial is 1. The same thing, move to the when x is equal to 1. Anywhere you are seeing x, put 1. X is in the lambda raised to the power x, so we have 1 factorial, then you have exponential minus 4. So 1 factorial is equal to 1, then the exponential minus 4 is equal to this, then multiply by 4 times 4 raised to the power 1 is 4, then plus 0. The next one is what? Exponential minus 4 times 4 raised to the power of 2. 4 raised to the power of 2 is 16. 4 times 4 is 16. Then the exponential minus lambda is this guy here. Then divided by 2 factorial simply means 2 times 1 times 0 factorial. And 0 factorial is equal to 1. So we have 2 multiplied by 1, which is 2. 2 multiplied by 1, which is 2. That's why we're having our 2 here. So by the time you do justice to this, we're going to have 1 minus 1 multiplied by this divided by 1 will give you this. 4 multiplied by this divided by 1 will give you this. Then 16 multiplied by this divided by 2 will give you this. So by the time you add 0.018315 plus the next one plus the next one, you are going to have 0.2381028. Subtract that one from 1, you are going to have your final answer to be 0.7619. That is how we got the answer. Did you get that, please?
Yes, sir.
Okay, lastly, let us check the final question under Poisson distribution. Now, 60 individual each susceptible to tuberculosis came in contact with a carrier of disease. The probability that the disease will spread from the carrier to any given subject is 0.2. 0.2. How many are expected to contact the disease? They are asking you the expected value. Please note that anytime you are hearing the word expected value is the same thing as your mean. Expected value is the same thing as what? As mean. So now they ask you to find the mean of Poisson, and then mean is the same thing as the average. Mean is the same thing as the average. Mean is the same thing as the expected value. So now remember that I told us that anytime you're having the small probability and then the sample size is large, the Poisson, the binomial is approximately to Poisson. That is, the lambda is equals to n multiplied by p. Yes. So now from the question now, 60 susceptible, that is our n is equals to 60, and then the probability that they will be affected by the tuberculosis is 0.2. Now the probability is small, and then the sample size is large. So now the lambda, which is the expected value of those people that will be contacted, will contract the disease, is going to be 0.2 multiplied by what? Multiplied by 60 multiplied by 60. Yes, in the course of doing that, we are going to have 12. That means 12 individuals will contract that disease. Any question, please? Any question, please? Are we still on the same page?
We'll still go back and read.
Sir.
Ma, yes, ma.
Yes, thank you very much, sir. So in this case now, if I get you right, that means it was because they were asking of expected value. They didn't specify a particular value that we should. They didn't say at least or at most.
They didn't ask you to find any probability.
Yeah.
They
So
just
it's
say
because they are
expected
talking of expected value. That
Yes.
means our expected value takes the position of lambda.
Lambda, which is mean.
Mean. Okay.
Yes.
Thank you, sir.
Did you get that, please?
Yes, sir.
Okay. So let us go and be drinking water with that one. So we are left with the continuous distribution. So our next contact, we are going to start with continuous distribution. I don't want to bombard you with continuous distribution now because it's involve you using some tactics. I'm going to be introducing you to standardized normal distribution. Then we're going to be solving questions. But I don't want you to look at that now. So we are going to start with continuous probability distribution function, which is we are going to be checking normal distribution function. We also have other continuous probability distribution function. We have the exponential, we have gamma distribution, we have Kumaraswamy distribution, we have so many distributions. That is, we have Gompa distribution. They are all continuous, but as far as this your course is concerned, it is only the normal distribution that we are going to be talking about. So our next contact, we are going to start with the normal distribution. If we can finish the normal distribution in the next 1 hour, then we move to what we call the statistical inference. And then let me quickly tell you about the statistical inference. Statistical inference is also divided into two. We have the estimation and the testing of hypothesis. Estimation and test of hypothesis. And under the estimation, we have the point estimate, and then we have the interval estimate. And under the testing of hypothesis, we have the Z test, we have the T test, we have the F test, and then we have the chi-square test. Then we can also be showing the relationship, which is called correlation. And we're going to be showing the association, which is called correlation. Or we can also be showing the relationship, which is called the regression. So those are the things that we have ahead of us to cover up with. Then the 15 question that is your rep sent to me, 14 out of it is statistical inference. So that one is telling you that how important is the statistical inference, because statistical inference is the bedrock of statistics. So on this note, we are going to call it a night. Thank you.
God bless you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.